Okay, so you've made it to the next step in your lesson. This is the next video that's going to kind of conclude your notes and explain the rest of the examples to allow you to do the practice and then move on to the checkpoint, right? So, problem 3, writing expressions with two operations. So, same as before, but I'm adding additional operations to those expressions that you're going to write. So these 3 examples here, 3 more than twice a number x. So I'm going to look for keywords here. More than and twice. So 3 more than, I would say, is 3 plus twice a number x. The way I would represent twice a number x, 2 times that number x. Or you could have written this as 2x plus 3. Either way, both of those work. Okay, next one. 9 less than the quotient of 6 and a number x. That's kind of got a lot going on. Less than and quotient. So I'm going to be thinking subtraction and division. Now, when we see less than, 9 less than means I'm going to be subtracting 9. That's important. The quotient of 6 and a number x. So the way I can only really write this one way. 6 divided by x, hopefully you can see that, minus 9. That's important, okay? It is not 9 minus the quotient. Those would be 2 totally different expressions. So when you see less than, you got to think that that's going to kind of flip around what we would normally think of, reading left to right. So less than, you're subtracting 9. Third one, the product of 4 and the sum of a number x and 7. So we've got product and sum. And I haven't said sum yet, but sum is the result of addition. So the product of 4 and the sum of a number x and 7. So the product, 4 times. And this isn't 4 times x. This is 4 times a sum. So whenever you hear 4 times the sum or product of a sum, we're going to have to put parentheses around that sum of x plus 7. So that sum, that indicates grouping those numbers together, okay? That would be a totally different expression if I didn't have the parentheses. So right now, pause the video, try the got it number 3, and then I will explain. So got it number 3. Same as up top, you should be able to kind of follow that. 8 less than the product of a number x and 4. So less than product. So product of a number x and 4. I would like to write this as 4x, not x4, just for cosmetic reasons pretty much. And 8 less than that would be that product minus 8. That one's finished. Twice the sum of a number x and 8. So twice and sum. Twice, we're going to say, means multiplying by 2 times that sum. That indicates we're going to group these, x and 8. And that one's finished. The quotient of 4 and the sum of a number of 12 and a number x. So when you hear quotient and sum, that means division and addition. So quotient of 4 and. So quotient, I'm going to draw a bar, kind of like a fraction, of 4 and something else. So 4 is going to be on the top over the sum of 12 and a number x. 12 plus x. And if you wanted to put that in parentheses because of the grouping, you could. That's fine. But when we talk about the quotient of something and a sum, that whole sum goes on the bottom, okay? So moving on to problem 4. Problem 4, using words for an expression. So these are a little more open-ended, right? So translating from algebra to words. The next example, what's a word or phrase you can use to represent these? The way I read this is the way I would write it. X plus 8.1. I'm okay with that. Totally fine. The sum of x and 8.1, fine. 8.1 more than a number x, great. Okay, next one. I could say 10 times a number x plus, put my plus sign there, plus 9. Done. You don't need to go any further than that. So if you want to say add, divide, whatever, that's great. You don't need to use sum, quotient. You need to know what they mean, but you don't have to use them all the time. Next one, the way I read it, n divided by 3. I could just say n divided, sorry about my handwriting, n divided by 3, and you've got it. Last one, very similar. I'm going to say maybe 5 times a number x minus 1. And I'm done, okay? If you want to use those words, product, quotient, difference, that's fine. But I'm trying to keep it simple. And if you want to write the actual number and not write like literally FIVE, I'm okay with that, all right? It's you just being able to translate between the two. So our last example, everybody's favorite, a context, okay? So writing a rule to describe a pattern. Serena and Tyler are wrapping gift boxes at the same pace. Serena starts first, as shown in the diagram. Write an algebraic expression that represents the number of boxes Tyler will have wrapped when Serena has wrapped X boxes. So, Serena starts first, right here, and then Tyler hasn't started yet. So you've got to look at the number of boxes each of them have, okay? When we look at this, since she started first, will she always have more boxes than Tyler? When we think about it, she does have a head start. Let's look at the pattern. She has 2, he has 0. She has 3, he has 1. So let's look. 2 to 0. Think of like keeping score. 3 to 1. 1, 2, 3, 4. 4 to 2. So I think if this pattern keeps up, yes, I think she will. She will have more. And how many boxes did she wrap before he started? She wrapped, looks like 2 before he started. All right? So this could be they're working at a job and he got there late. Could be really anything. So examining the situation. What phrase in the situation could be rewritten as an algebraic symbol? What is the associated symbol? Well, the way I think, if I look at the situation, Serena starts first. I'm going to say something about she always has more, all right? And I think about the word more. I'm going to think of addition, okay? That's the way I see it. She's always going to have a few more than him, okay? So when she's wrapped X boxes, she's always going to have more, or you could think of it this way, I guess. He's always going to have less. It depends on who you're thinking of, if you're Serena or you're Tyler. So when she's wrapped a certain amount of boxes, he's always going to have wrapped 2 less boxes. So let's just say she's wrapped X boxes. He's always going to have wrapped 2 less than her. He's just behind. They're working at the same pace, but he's always going to be behind if they're at the same pace. So if she's wrapped X boxes, he's wrapped X minus 2 boxes. Okay? I could also represent this from another perspective. I could say if I'm Tyler, I've wrapped X box. Let's say I'm Tyler and I've wrapped Y boxes. Change it up. Serena has always wrapped 2 more boxes than me. Okay? So that's the idea, is that you're comparing them. And that's important for a lot of things, to recognize patterns. Okay? So the got it can look a little challenging, but I want you guys to try it. Pause the video, try it in your notes, and then I'll explain it. So if you need to revise something, that's fine. So in this next one, suppose you draw a segment from any one vertex of a regular polygon to the other vertices. A sample for the regular hexagon 6-sided shape is shown below. And this table is really going to help us find that pattern. but we talk about a hexagon has 6 sides. We can make 1, 2, 3, 4 triangles. And that pattern follows for every shape, okay? So, this is the number of sides, this column. This is the number of triangles, okay? So, if we're doing this is kind of like the last example. We see the pattern. The number of triangles is always going to be 2 less than the number of sides. So, I could say number of triangles I can make is 2 less than my number of sides. Pretty straightforward. There's always 2 less. Now writing it as an algebraic expression, some things we got to recognize is what we're looking for, okay? So if I'm looking for the number of triangles, I'm going to take the number of sides and subtract 2, okay? So this is the number of triangles. I'm just going to use the symbol for triangles, okay? Now, it's a little bit different if we were trying to find the number of sides. Then we'd maybe do the number of triangles. I'll just use t. Maybe that's not a good one to use, but the number of triangles plus 2 gives me the number of sides. So every expression, pretty much, that we can think of can be written in multiple ways. So now you're ready to move on to the next step. You're probably ready for the practice by now. Make sure you use these notes in the practice. That's very important, okay? These notes are for your own records, okay? So you can move on to the next step in your lesson.